Today's class we will discuss the decision making and branching in C language. So particularly we will discuss if else and else if commands. So conditional statements or control statements. C has some decision making capabilities by supporting the following statements: if else if, then switch, go to, etc. So these are the commonly used decision making statements or conditional statements. They are called decision making statements or control statement because these statements have the ability to control the flow of execution. In normal cases, in the last programs, we know that it is executed sequentially from the first statement, like int a b, two variables are defined, then maybe their values are initialized, then printed, then if there is any assignment that is done, say c is equal to a plus b, then print the result. It's going in order. There is no single statement has the authority to change the flow of execution. It is just executed sequentially. But in case of conditional statements, we are giving a condition, and based on that condition, execution flow is varied. So that's why such statements or such commands are called control statements or conditional statements. So first we will begin with if statement. So as we know, if is the keyword. It allows the computer to evaluate the expression first, and depending on the value of the expression, it transfers the control. We discussed in logical operators, whenever a condition is verified, if it is true, the value will be 1, and if it is false, the value will be 0. So that is valid throughout the subject. Whenever we learn C, it's like something true means the value will be 1 and false corresponds to 0 value. So this point of program has two paths to follow. The point of program means when we use that if statement, at that point there are two paths to follow. One is corresponding to the true condition and the other is for the false condition. So this is the flow chart. Like we are coming, the execution is in order. It is being uh, carried out sequentially, and at this point it cannot move in a single path. There are two options. If it is true, it goes through one path. If it is false, it goes through other path. So here there is a branching, and the syntax is if you can give the condition. Okay, so this is the syntax. If is the keyword. So let's straight away go to a simple program to understand how to use if statement. So let's write a program to check if the number entered is negative. So the requirement is just to check if the number is negative. So here I have just typed the beginning part. So we need a number, say int a, then enter a number, scanf %d and a to enter that number. Now we are writing a program to check if the number is negative. That is the only requirement. So we are checking if number a is negative. How to check that? If a number is less than 0, that means it is negative. So if is the keyword. If within brackets you write a less than 0. If a less than 0, maybe you have to give a print. Printf / number entered is negative. Okay, so this much is the program. So we can just execute it. We are giving a number, say 45. There is no option because like there is no output. We have not given any statement corresponding to positive number because we are concerned only about the negative number. So 45 is not negative, so we are not practically getting any output. Again, let's try a negative number, say -20. Okay, number entered is negative. So we had two options. First we entered a positive number, there was no output. Then we entered a negative number and you got the result, number entered is negative. So you can understand that if this condition is true, the immediate statement is executed. Okay, when we gave a positive number, what happened? This condition was false. So the immediate statement was not executed. Okay, if after that if we gave some other thing to do, it would have been performed. But here after this, if condition is true, it will go to the statement. But after that, there is no other statement to be executed. So because of that, if the number is positive, there is nothing else to do. If it is negative, immediately it will go to this part to print number entered is negative. So this is a simple program with if statement. So here test expression in the last program we what was given a less than 0, that was the expression we gave here, and if it is true it has to execute something. Okay, so here we gave a print that number is negative. If it is false it will move to statement X, and this is common in both cases. Even if the statement is true or false, it will commonly go to the next statement. So in the last program there was no statement, so statement X was missing, there was nothing to be performed after that. So because of that nothing was done. Okay, then again the execution will go in order, or sequential execution will happen after this. But at this point what will happen, there is a branching. If it is true it will execute the statement block, if it is false it will go to statement X. And when we use a simple if, one thing to be noted is that even if it is true or false, the statement X will be executed. Even if false, it goes to X. Even if it is true, it will go to X. Okay, so this is common. This is common even if the statement is true or false. But this occurs only when it is true. Okay, so that's the thing to be noted. Statement block, this can be a single statement or a group of statements. So here in the last program we had a single statement, so we need not use brackets. But if it's a statement block, more than one statement is there, we can use a we can use brackets. In such cases we call it as a statement block. It's a group of statements. If it is true, statement block will be executed, otherwise it will jump to statement X. Hope things are clear. And this is to be noted, when the condition is true, both statement block and X are executed in sequence. Okay, and this is the syntax. Within this bracket, whatever we write will be executed if the condition is true. So here, this is the expression. Okay, if the expression is true, this will be executed and this will be executed. But if it is false, whatever is written within the brackets will be excluded, and it will, if it is false, it directly goes to statement X. Okay, and next is if else statement. From the word meaning itself we know if means it's a condition, else means if that condition is not satisfied, what to do, that is given in else. So we can compare the flow chart. In the last case, we know that there was only one statement block. That is, only if it is true, it can perform something. If it is false, we don't have an option. Like, even if it is true or false, it will follow the rest of the statements. So there was no option to give some commands if the condition was false. If false also is to be executed, we can go for if else. That means if it is true, it will go for the true block statement. If it is false, it will go for the false block statement. In both cases, it will commonly go to statement X. Okay. So if it is true, true block statement, that is true means it is going this path. So only if it is true, this path will be taken. If it is false, this part will be taken. But true or false, commonly statement X will be executed. Okay. And another thing is, both true and false will never get executed. Why? Because when an expression is verified, it can take either 0 or 1. If it is true, it will take the value 1, or if it is false, it will take the value 0. So both paths will not be taken. Either true block or false block will be executed, but after that, it will go to statement X. So this is just to compare. This is the flow chart corresponding to if. Okay, this is the statement corresponding to if, and this is corresponding to if else. So you can find the difference. Here only true is addressed in case of if, but in case of if else, both true and false conditions are addressed in case of if else. Okay, so let's modify the last program. Here we gave only one case. Okay, if a less than 0, printf number entered is negative. So now we can give, say, else, we'll give printf. Else, if a less than 0, that is the true case. Number entered is else, that means it is not negative. So you can give print like printf slash n number entered is positive. Okay, so now it makes more sense. Okay, earlier we remember when we saw the output corresponding to a positive number, there was no output. But here we have option in both cases. If it is negative, it will print as negative. Else, it will print as positive. So let's check. Enter a number, say 23. Number entered is positive. Again, let's check. Minus 13. Number entered is negative. So in both cases you are getting the result. So this is a simple program with if else. We can do one more program, that is to find the largest number. So let's modify this program. Let's enter two numbers from the user and scanf. We need two numbers, so percentage d and a and b. So now you have two numbers, and now the condition we are giving if a greater than b. That means a is greater than b. So we can give the print as percentage d is greater than percentage b, and here which is greater, a is greater. So you can give a comma b. Else, that means if this is not right, then b is greater. Okay, let's check the output. Now let's check the output. Enter two numbers, say 12, 25. 25 is greater than 12. We can do the other way. Say first number is greater, say 30 and 10. 20 is greater than 10. Okay, so here in this case also, this is the condition, if condition. If it is true, something to be done, else another thing. Okay, and if, for example, if we are writing something after this, say we can give a print like the comparison is done. Okay, we are writing, say comparison is done. Okay, so we are adding this also and we are executing. First we will check the true option, say 25. 20 is greater than 5, the comparison is done. Now let's take the other case when first number is smaller, say 5 and 20. We will give 5, 20. Again you got the comparison. So in both cases the comparison is done. That thing is printed in both the cases. So that means this statement is common for both the true and false cases. So if this is true, this is executed and this is skipped. When it is false, what happens? This is skipped and it will print this. In either cases, it will print this because this is common. Like similar to statement X in the flowchart. This is common even if it is true or false. Hope it is clear with this simple program. Okay, so this is the corresponding the true statement. This is corresponding the false statement. Even if it is true or false, the statement is executed. Now another thing is corresponding to this true block. If you have many things to do, what you have to do is you have to enclose it in curly braces. Say if till now there was a single statement to be done, so I did not use this bracket. So here if you have more than one statement corresponding to true condition, you can enclose in a bracket. Say percentage is a is greater than b. You can do something like you can add another variable, say large. and you can assign large equals. Here A is greater, so you can assign large equals A. In the second case, what you can do again, you can add curly brackets. So if there is more than one statement, you can enclose it in bracket. That was the point which I was trying to convey. In this case, you can assign B to the variable large. So here what we did is we gave the print. Along with that, the larger value is assigned to the variable say large. So here you can write say printf printf the largest number entered is percentage %d, and now you have a variable to store the large number, right? So you are giving it like this and you are compiling and running. Enter two numbers 12, 50. 50 is greater than 12. The comparison is done. Largest number entered is 50. Okay. So now first was the smaller number. So now let's check the other way. First we will give a larger number. Say 45 and 5. 45 is greater than 5. Comparison is done. Largest number entered is 45. So these two statements are common for true and false. So that was done outside. And 45 is greater than 5. And larger, that variable is also assigned. So both these things are done corresponding to this condition. So the program is clear. Corresponding to true statement, if you have more than one statement, you have to enclose it in curly braces. Corresponding to else also, if you have more than one statement, you have to enclose it in curly brackets. If you have a single statement, you need not add curly brackets. And after this if and else, whatever you write will be executed sequentially irrespective of the condition. That is, even if it is true or false, here the statement 17 and 18 will be executed. So this is a very simple example to discuss if-else statements. Next is if-else-if statement. Earlier we discussed a simple if statement and if-else, where a condition is checked. We have two options. If it is true, it follows a set of statements or it executes a set of statements. If false, it executes another set of statements. And now the third cases if else if. Here it's a ladder type structure. You can see various conditions are checked. So let's go through it. The conditions are evaluated from the top downwards. So first condition is verified. If it is true, it will directly go to statement X. If it is false, it will go to second condition. Again, if it is true, it will go back, or else it will move to condition 3. That's why it is called a ladder type structure. Whenever a true condition is found out, it will come out of that ladder, or the control is transferred to statement X. Statement X is common. Okay, that is the first statement after this condition block. So whenever a condition is found as true, it will go back to statement X. Or else if it is false, it will go to the next condition like that. Okay. So whenever it is true, it will skip the rest of the conditional block. So when all the n conditions, if all the n conditions are false, there is an else option where the default statement is given and that will be executed. So in the first case in if statement, we had provision to just check one condition. In if else, we check one condition, and if it is true, one set of instructions, and if it is false, another set of instructions. Here you have the provision for checking various conditions and in order. Okay, so it will be more clear with this example. This is a typical case where we have to calculate the amount to be paid for the electric unit consumed. So in such cases, or when you are asked to calculate the grade of a student, we have different options, like if it is above 90 A grade, 80 to 90 B grade, 70 to 80 C grade, like that. So these are various conditions and they are dependent. A student cannot simultaneously get A and B and C. No, it will be a range. So if it is 90, it will be A grade, or else if he gets A, then there is no chance to get B or C. So that is else if. Okay, that is if the first condition is not satisfied, then check for second condition. If that is not satisfied, go for third condition, like that. So here you can check consumption units between 0 to 200. So if the consumption unit is up to 200, it is 0.5 per unit. But if it is between 200 and 400 units consumed, it is 100 rupees plus. Above 200 units, how many units are there? 0.65 for each unit. So like that, it's a different slab given. For the different range of consumption units, the rate will differ. So we are going to write a program to print the amount to be paid by the customer based on the units consumed. So here itself I have given the code. So first requirement is we need to get the consumer, the units used by the consumer. Okay, or the customer. So int units. Units will be in integer. So we give it as units, say customer number. Also we give as an integer, and the charge to be calculated, that will be given as float, because we can see that all the rates are in point that way. So its charges will be float type. So from the customer, we are getting the value of customer number and the units consumed. This is more important. We just need the number of units. So as integer, it is given percentage D and units. So now you have the value. Now we are proceeding with the calculation. So this is the values given in the question. So for convenience, I am putting it here also. So first case, if units is less than or equal to 200, what is the value? Charges equals 0.5 into units. Hope that is clear. This is the first condition. That is the first condition when it is less than 200. Less than or equal to 200, because here it is from 201. So 200 is included in the first block. So if units less than or equal to 200, charges is equal to 0.5 into units, because number of units is given in this variable. Now, if this is correct, then it will not pass through the next condition. So next, if it is greater than 200, it has to check for the second condition. So you write else if. Else space if is there. It's not a single word. You have to put space between else and if. Else if unit less than or equal to 400, that means it is between, if it is less than or equal to 200, this condition would have satisfied. So this means that the units will be between 201 to 400. If that be the case, it is 100 plus 0.65 into units more than 200. So we give units minus 200 into 0.65. Next, again, else if unit less than or equal to 600, that is the third case when it is 230 plus 0.8 into units minus 400. Hope it is clear. And the fourth case, 601 and above. So if these three conditions are not satisfied, then obviously it will be a value greater than 600. So all the other cases will come under the last condition. So you end it with else. Else is compulsory in if else if statements, because there is a default thing to be written. So else charges is 390 plus, here it is 1. So 1 into 9 units minus 600. So now charges is calculated. Now you just need the print. Print customer number, to print that percentage D. Charges equals, you round up to 2 decimal points. So that's why we write it a 0.2f slash n customer number comma charges. Okay, charges is the value that is calculated in this if else if conditional block. Thank you.